Hey guys, my name is Lloyd Patron and I will be introducing you to PC building. This presentation is not meant to delve too deep into components or stretch too far from the main goal, which is trying to assemble a simple PC. And here we'll be understanding the parts, what they do, and where they belong. So starting off, we have our motherboards. This is essentially the body of the PC and connects all the components to work together. All motherboards essentially have the same ports and slots for the components, with the exception of the CPU socket, which is found here in the middle. AMD's AM4 sockets are different from Intel's LGA sockets, and I'll explain that in the next slide. But they all have the same DIMM slots, M.2 slots, this being having a heatsink and this one not having one, a PCIe slot, and your SATA ports. And this is what a CPU looks like, also known as the central processing unit. The left being fit for an AMD's AM4 motherboard and the right being fit for Intel's LGA motherboard. They essentially do the same task, but the manufacturers of course compete and try to make one more optimal than the other. So the CPU acts as a brain for the whole PC, meaning that everything that your PC has to do, it would go through the CPU first. Much like the brain, it performs calculations and digital logic that allows your PC to execute a given order. RAM, also known as random access memory, is a temporary data storage media. I say temporary because nothing ever stays inside the storage of RAM and is subject to be permanently lost when the computer is shut down or runs out of power. RAM is found in almost every device that requires fast movement of data, and the speed, shown in megahertz, is the speed of the RAM and how fast it can access its memory within a given second. Depending on the load that your PC is undergoing, the amount of RAM can change the performance of your system. For example, working on documents and browsing the web requires minimal RAM, while gaming or heavy load of editing requires more. Here is a picture of the DIMM slots, also known as RAM slots. This is where the RAM sticks belong and allow the computer to access the memory inside the RAM. The job of these slots are for holding the RAM in place and regulates the speed of the sticks. Next, we will be talking about permanent data storage, also known as typical storage media drives. These devices are meant to store the operating system, such as Windows, Mac OS, or Linux. In the picture to your right, you may notice the different types of storage that you can have in your computer. The first two being a solid state drive and the third being a hard drive disk. The first is an M.2 NVMe SSD. It does not use any SATA cables and connects directly through your motherboard, unlike that 2.5-inch SSD and 3.5-inch HDD. The SSD and HDD are connected via SATA cables to the power supply and then connected by another SATA cable to the motherboard SATA ports. Here you can see where each storage device is meant to go into. The first picture is an M.2 slot and holding the M.2 and NVMe SSD. The second image is an SSD that is connected to the SATA port but not connected to the power supply, which plugs in through the other half via SATA cable. Next is the GPU, also known as the graphics card. The GPU is responsible for taking some of the load off the CPU in calculations and renders it to video quality. Because graphics are improving in games, GPUs are responsible for rendering in softwares. Because the GPUs are very strong components in a PC, they require a lot of power, much like the CPU. This is where the GPU is connected via PCIe slots, also known as Peripheral Component Interconnect Express. This is responsible for delivering connectivity to your components to your monitor or other depending on the devices that you have. It can be used for other things such as Wi-Fi connectivity, Bluetooth, and many more. And lastly, the power supply to power all the components in our PC. This provides the energy that the CPU, GPU, and motherboard need in order to function. Depending on the components that are chosen, a higher wattage PSU is recommended so that it gets optimal performance and doesn't fail. A PSU has two different aspects to it: the efficiency and its wattage supply. These can be found on the box. The wattage is shown up front in the image. In this image is a 500-watt power supply. The efficiency of a PSU can be found by an 80 plus certification, which can range from white, bronze, silver, gold, and platinum. This is what a typical power supply looks like, but the ports may differ among them. As you can see here, I highlighted where each input and output would be. The 28-pin port on the PSU is connected to a 24-pin port found on usually the right side of the motherboard. The 8-pin port on the PSU connects to the top left of the motherboard to a port that ranges between 4 to 12 depending on how recent it is and how much power it needs. The port highlighted in orange are pins on the PSU that have a SATA cable and are connected directly to the SSD or HDD. And finally, the 8-pin power supply cable will directly go inside the pins found in the GPU. So there are many applications of PC building and it improves a lot of things. So technology will always advance and computers will advance with it, and understanding those things will surely help understand what they do and what they mean and what they can uh, do to us. Having complete control over your customized system is a great thing to have because it's your own customized thing and you could take things out or put things in to your liking. And PC building also improves problem solving skills, such such that it helps in ways to go over problems that you can face because PC building isn't a straight line and there you will face bumps and problems along the way and it's your job to do research on the product or just try to find a way around it. And it teaches responsibility of the parts that you carry because these parts are very expensive and they could break within a single drop, such as the CPU and the pins that they have, they can malfunction and the system won't work if even a single pin is broken or out of place. And lastly, you become a part of a community that understands what a PC is and what components are put in a PC. And you'll be able to understand the cost of having a PC and the components' values. And I hope you guys enjoyed my presentation on how to build a PC. Thank you.